NVIDIA's RTX video super resolution feature is now available. It is named VSR, confusingly, because there's an AMD technology from a very long time ago, also called VSR, but this one's different. RTX video, we've talked about, it takes video playback, so not in games, but something like watching a Twitch stream or this video, and it takes a low resolution source from the stream and upscales it up to 4K, depending on a bunch of settings that we'll talk about. This is supposed to enhance clarity, and we wanted to put it to the test to see if it works, first of all, and if it's worth using or how well it works. Because in theory, if this goes the route of DLSS and just gets a lot better with time, kind of giving away the end here, then you could actually benefit greatly from localized improvement to the video, so you can stream it at a lower quality if you have maybe bad internet or something and still get a decent experience. But we're going to test it today, so let's get started. Before that, this video is brought to you by Montech's Metal DT24 base. This 2-fan tower cooler keeps a simple black and metal look to match most build aesthetics, and it runs a 6 heat pipe design with 2 towers and 2 fans for higher performance air cooling. The Metal DT24 base can also accommodate taller memory modules because it cuts back the fin stack closest to the first DIMM slot. The Metal DT24 base uses a standard mounting mechanism and is easy to install. Learn more at the link in the description below. VSR claims that it leverages the tensor cores present in RTX GPUs to improve the quality of video playback. And specifically, this works on the 30 series and the 40 series today. It's available now. The 20 series is going to be added, but it doesn't work yet. NVIDIA is presenting this technology primarily as a way to get more detail in low bitrate scenarios. And it specifically calls attention to Twitch streams, to lower quality YouTube playback, and also they mention as sort of an interesting scenario, if you want to save data by watching a lower resolution version of the video. So either you have a limited bandwidth and you're using it for other things, or other people in the house are using it, or maybe you have a bandwidth cap with your provider. That's one of their scenarios they lay out. It's a little bit like DLSS in games, but less advanced. As a quick reminder, DLSS launched and it sucked for a lot of games. So in Battlefield, whatever version it was that it launched with, it looked the same as smearing Vaseline all over the player's camera. And in Final Fantasy 15, there were all kinds of artifacts. It got a lot better though, and is actually at a point where DLSS is something you might want to use now. We'll see if RT video goes the same way, but it may have to follow that same trajectory. Any generic video stream will work with this. It's pretty simple in that regard. There's nothing, you don't need to add support as a developer, but there is browser support. So right now, it only works in Chromium browsers. It works in Chrome, and it works in Edge. If you use Firefox or something that's not Chromium-based and explicitly supported here, it just doesn't have the feature. Simple as that. There are a lot of specific caveats with native monitor resolution, for example, the video player resolution, the video resolution itself, what you click in the gear on YouTube. We also collected some information on performance impact. You can see some of that now. We'll talk about it later, though. And resource utilization. Ultimately, though, this entire technology is about making things look better. So what we need to do is just look at some footage and see if it looks better. And then we'll explain it all at the end of this video, how it works at a technology level. So comparisons, we've taken a lot of high quality 4K captures, and we looked at the same couple seconds of one of our videos for every quality step from 720p to 4K with VSR on and off. We also looked at some Twitch streams. We looked at some, for example, Asmongold streams, EVGA streams of different types of games. So we have FPS, Elden Ring, just talking, some football game that EVGA was playing, and that gives us a good cross-section. NVIDIA specifically did call out Twitch, so we're going to use our own videos as the initial comparison because we have source footage here. So we have the most information where if we encounter something we're not sure if it's reconstructing that which never existed, easy enough, we check our source footage from the camera and see if it did. And then we're going to look at the Twitch stuff. Bear in mind that all of this footage was already run through some kind of compression the first time, whether that's YouTube for ours or Twitch for the others. And that means it's getting crushed and recompressed again on a second upload. So it's possible that some of the things that we talk about in the really tiny details here today, the smallest stuff we're going to be talking about, it's possible you won't see what I'm talking about, And I promise you, it's not because we've gone crazy and we're making things up. It's probably because it got crushed out of the upload. But we'll see. This is one where, I mean, this is how it works when you try to do image quality comparison through multiple layers of compression. So we'll zoom in on the elements to show the most detail possible, and we recommend you change this video quality to the highest setting that your playback can sustain, because otherwise you might just be getting crazy compression and you won't see anything that we're talking about. Okay, a blind test is up first. This is always fun to do. So what we're going to do is pop up some videos on the screen. And this is a test, one, for bias, and two, to just give you time to see if you can see the differences and which one you prefer without us telling you which is which. We're switching between VSR on and off. The left will always be one of them, and the right will always be the other one. So you just pick one side in this test. We'll tell you the resolution of the footage in a text card on the screen, but we won't tell you whether VSR is on or off. And I'll keep talking for a second while the editors swap clips for you, so try to come to a conclusion on which has VSR enabled without pausing the video to inspect too closely. If you have your eyeballs glued to the screen, then it's not working very well. Okay, hopefully you've come to a conclusion on those clips. Now we're going to do that again, but this time we're using a different resolution. It'll be the same side that's enabled, so just try to come to a conclusion of if you still agree with yourself, and if you do, which side is off or on. We're going to reveal them now. The one on the left was enabled the whole time, while the right was native the whole time, or at least native capture and then re-upload. Leave a comment below and let us know if you got it right or not. There's no shame at all in getting it wrong, because that's kind of the point of the test. That's an important result too. A negative result is a result. We're also curious if you think it was meaningfully different. Okay, time for the revealed comparisons. We'll start off with a shot from one of our own videos at 720p and with VSR off. We'll look at the bottom left first. Here we can see the text for the credits, the handle of a screwdriver, screws on the mod mat, and the screw tracking grid itself. The bottom half of the grid is slightly out of focus, so don't mind the blurriness there. As expected for this level of zoom at 720p, all of the edges are soft, and there are compression artifacts around the text. The screws themselves lack definition, and the horizontal lines of the grid are nearly non-existent. With VSR toggled on, edges are more discernible everywhere. The text is cleaner, and the edges of the screwdriver are more defined. The screws no longer hurt your eyes to look at, but the horizontal grid lines still barely show up. There are also some artifacts of the VSR process that are visible here as well. Though the text is sharper than without VSR, there's a crunchy sort of color variation in the flat gray background that wasn't there with VSR off. Off to the right, there's a similar situation with the text on the alcohol bottle. It's more readable with VSR on. So looking pretty good for VSR so far. At the center of the screen, we have an example of high contrast detail in the shirt. It's also the most in focus. VSR cleans up the 2022 disappointment design, and it makes the wire for the microphone a lot more defined. As an example of motion, my left hand, or the right hand in this frame, is moving upwards in the shot. VSR cleans it up nicely with a few of the blocky artifacts being smoothed out from that motion. It's almost compensated enough to make me look more human and less robotic. Moving on. Another interesting behavior here is that out-of-focus background elements, like the items on the shelves in the left side of the frame, become a little sharper than they should have been when VSR is on at 720p. If we toggle to 1440p with VSR off, we see that some of these background objects get blurrier versus 720p VSR on. This is just a situation where VSR doesn't really know if this object should be in focus or not. Because remember, sharper or more in focus doesn't necessarily mean better, but the human brain likes to think that it does because we like to see things with clarity. But that's not how they're always intended to be shown in a shot. In this instance, VSR is just making an assumption. It's picking one, and it's deciding that the shapes should be more defined. Now we're going to move to 1080p with a different image. This is a slow-moving B-roll shot with lots of fine detail in the subject. The big change here is just that we've modified the resolution. Take note specifically of how the thin text on the lower half of the CPU's IHS is readable but blurry. Also note how the gold contact pins look just in general. With VSR on, both of these areas snap into higher clarity. That said, these are some of the minute details, and we're pixel peeping and freezing frames just to see them. If we zoom back out to the full frame and toggle VSR, you may be able to appreciate how subtle the change is in practical terms. Hopefully this comes through after YouTube has another go at processing the footage. And as we swipe between VSR on and off when fully zoomed out and at full speed of a video, whether that's a Twitch stream or our own video, it's difficult to quickly discern which footage has gone through VSR just at a glance. Zooming back in, we'll also point out that VSR is causing some noise in the image to become more pronounced, particularly around the model name and the text on the IHS. It looks like VSR is hooking onto some of the compression artifacts in the original 1080p frame, and it's treating them like real detail that's intended to be kept. When we look at the 4K image as a comparison, we see that those color variations aren't actually there. We see another quirk on the right side of the Aorus robot's head. With VSR on, the look of the surface implies a subtle ripple-like texture that's not actually there in reality, or in the source 1080p frame, or in the full 4K frame. Again, this is really fine detail that you will never see in normal conditions, but it's an interesting result of the process. At higher resolutions like 1440p, the difference is so subtle that you have to zoom in very far and actually attach your eyes right against the screen to analyze the image closely enough to point out differences with VSR on. This really isn't what VSR was advertised for, so we're giving it a pass on this one because not really the intended use, but you should also be aware of that. We performed subjective analysis on a few different Twitch streams to see what the experience was like in those conditions. Twitch is interesting because the video there is limited to a constant 6,000 kilobits per second. That means when there's lots of motion on screen, the quality has to go down temporarily to compensate. NVIDIA calls this out as a good place to see the effect of VSR, but we don't really agree, at least not in all circumstances. For example, when watching fast-paced FPS gameplay, static game UI or stream overlay elements got a little bit of a touch-up. The game itself underneath, though, nothing. At least nothing we could see. And these touch-ups on the UI elements are rendered completely meaningless when the screen moves quickly enough that the entire thing turns into pixel soup anyway. It's a torture test for VSR, and it just doesn't have enough information to work with to create anything actually better. Vampire Survivors gameplay, for example, would be another one where there's just, at the end game of a round, there's so many enemies on the screen that the bitrate problem always shows up on Twitch. And VSR can't fix it. It's just impossible, because you can't create from nothing if the information just wasn't there to begin with.
Quick bitrate? Oh, bitrate's fine. Bitrate's fine, guys. If you're getting low bitrate or you're not seeing all the pixels on my screen, it's just your computer. Contact your ISP.
In scenes of moderate movement, the boost from VSR is better at 720p than it is at 480p. For example, look at the number 56 player in blue. At 480p, VSR is mostly removing noise. It's not adding a lot of detail. At 720p, however, VSR makes a pretty obvious difference for the better. All of the shapes are more solid, with a big reduction in compression artifacts. Games with slower camera movement, like Elden Ring, or anything turn-based especially, exhibit an improvement further down the resolution stack. In this clip at 480p, the image tightens up with VSR on. Text is made more readable, UI elements are clearer, and detail on the enemy's shield in actual gameplay becomes more defined. The difference at 360p is marginal. Base detail is low enough that VSR today, as it exists right now, struggles to do much with it. That said, it still did a good job of removing compression artifacts in the background of the dimly lit cave that the streamer here seems to be sitting in. Fun fact, Jeremy, the scriptwriter for this one, wrote that line, and I'm not sure if he's talking about a dimly lit cave in the game or actually where Asmongold is sitting, but I guess I'll find out when you do when I watch the video. So in short, the experience on Twitch changes a lot from moment to moment. Sometimes it's pretty good and genuinely helps with clarity. When the motion is fast and the source quality tanks though, there just isn't enough for VSR to do anything with. Here's how all this works, or at least how it's supposed to work. They need to do some refinement on some of these features. 30 and 40 series only right now, 20 is coming. We already said that. VSR works by using a deep learning algorithm that performs it tries in a single pass of video, because you only get one, to reduce compression artifacts and to upscale the video itself. So specifically, NVIDIA names, quote, blockiness, ringing artifacts around edges, washout of high frequency details, and banding on flat areas as the types of imperfections that they're seeking to improve with VSR. NVIDIA's blog post goes into more detail about how the final image is created. They said, quote, the network analyzes the lower resolution video frame and predicts the residual image at the target resolution. This residual image is then superimposed on top of a traditional upscaled image, correcting artifact errors and sharpening edges to match the output resolution. NVIDIA says it trained a model on a large amount of images for this, and it specifically noted that it trained it on different resolutions and different types or varying amounts of compression while encountering gaming content and real-world content alike. So they're trying to do all of it. The focus, though, seems to be on those really low bitrate streams like Twitch. Like we alluded to earlier, this VSR method of upscaling, first of all, it should work on basically any video playback, not just Twitch streams or so. You could actually watch YouTube videos like this one and apply it here. But it also puts a load on RTX GPUs. So specifically, it puts load on the tensor cores. Tensor cores are what you're going to use for other RT-enabled functions in gaming scenarios. So there are some places where it would really not make any sense to enable this. For example, if you have video playback on one monitor and you're using VSR and you have a game with tensor core utilization or something else utilizing tensor cores on your main monitor, they're going to be fighting for resources at least a little bit. We did, however, notice that the tensor core load changes when altering the source video resolution. The higher the source resolution, the higher the compute_0 load. We also noticed that general GPU utilization was slightly lower when VSR was enabled. If we have to speculate why this is happening, the guess that our team came up with is that maybe it's moving the scaling task from the instruction from the CUDA cores, the FP32 cores that would be calculated for in general compute load, over to specifically the tensor cores. That's our guess. Doesn't really matter. I mean, it works the way it works, but it'd be nice to understand it, and that's our current understanding. It's really a small thing, but NVIDIA makes several statements about the poor results that basic bilinear upscaling found in most browsers would get you versus VSR. These statements from NVIDIA aren't literally untrue, but it feels a little bit like saying that box truck handles corners really poorly. It's not built for that. We might as well criticize VSR for not working well for things that are most things, I guess. But at least for the things they designed it for specifically, you can kind of see the difference sometimes, like in those Twitch streams that aren't high movement games. The point of standard bilinear upscaling isn't to improve the perceived quality, it's to make stuff look bigger. Like, that's the whole point. So to make the content look larger, basically. It's a little bit of a weird statement to make in their marketing. Anyway, here's how to enable VSR. If you want to try it out yourself, it's simple if you have a card already. So you do need a 20, 30, 40 series GPU. 20 may or may not be implemented by the time this video goes up. We don't know. Also, pro-level RTX GPUs work. And then you need to update to the latest graphics driver, which is version 531 or the Quadro equivalent. After installing the driver, you open up the NVIDIA control panel, you navigate to the Adjust Video Image Settings page, and then on the right, check the section for RTX Video Enhancement with the Super Resolution checkbox, and that's where you'll enable the feature and set the desired quality. You'll also need the latest version of Chrome or Edge to see this, at least as of filming, and to see the change, we recommend locking the video player to a fixed resolution. This is actually pretty important. You then have to make the video large or full screen. There's some challenges here where VSR will only trigger when the video player itself is higher resolution than the source. So for example, if you have a 1080p monitor and you're watching full screen, VSR will only kick in for videos under 1080p. On YouTube, you can see the current resolution information by right-clicking the video and choosing Stats for Nerds. The current or optimal res is the resolution of the source video, and viewport frames shows the current size of your video player. Viewport resolution has to be higher than current for the feature to even engage and work. We'll put some video on the screen now. You can try VSR yourself on this stuff. Pay attention to the edges of the high contrast or static elements to see the most obvious differences. Any of our videos for charts especially would make it easy to see this. If you don't see any change, you may need to restart your browser, but also remember it doesn't work with Firefox. So RTX Video Super Resolution replaces the built-in upscaler in Chrome and Edge. And we don't think it makes much of a difference as compared to, say, DLSS, where DLSS these days has a big impact on games, very easy to see. Depending on what you're looking at, you could argue that it looks better than native. Purely on a technicality, it's not higher resolution than native, but it may reconstruct the image in a way that appears better to the human eye. That is not the expected outcome, but it is one of the outcomes depending on the scenario. This isn't there yet. So this can't reconstruct from information which doesn't exist. If there's limited information, it has trouble reconstructing, like if it's too limited. If it has too much information, it doesn't really do much either. So it's kind of a narrow band where it works well. And it's a narrow list of types of content, but billions, millions at least, assuredly, but probably billions of hours of that band of content are consumed every year. So it's at least a high volume scenario. In our experience so far, 720p seems to be the best bet for VSR to show an outcome. Edges become sharper and some compression artifacts are reduced. Below that, it's difficult to tell if anything positive is actually happening, and at higher resolutions, the improvement's so subtle as to be actually pointless. VSR also appears to be better at static or slow-moving content, maybe like animated video, anime or cartoons or something like that might do well here where you don't have quite the frame rate as you would for Quake, for example. It completely falls apart when the motion is fast and chaotic, when someone's flicking the mouse around the screen. Doesn't really work. Even the sharper UI, it becomes a mess at that point because the entire video is a mess. So there's no real downsides to having the feature on if you already use Chrome or Edge. Technically, there's a performance hit, but it's not one you'll see unless you're doing something with those tensor cores otherwise. So you could just turn it on, and then if it doesn't bother you, which it probably won't, cool. But you may not notice an improvement. It's one of those like, well, it's nice when it works, and when it doesn't, then whatever. But ultimately, if you only use, say, Firefox, we don't think this is enough of a change to switch your web browser to something you don't like or don't want to use. So, and maybe they'll add support in the future. The only situation we'd specifically advise leaving it off is going to be when you're playing a game with RT features that use the tensor cores on your main monitor and watching a video on the secondary monitor. Then you should explicitly turn it off. But as a final note, we heard a rumor that Intel may be coming out with similar capabilities, and it may be able to work on AMD in the future as well, based on some of the stories we've seen just as we were writing this script. So it looks like this is a thing that everyone's going to be trying at least. That's it for this one. Overall, that pretty much sums it up. Not a huge impact. It kind of works. And if it goes the route of DLSS, then it'll be a big improvement in the future. And if not, then it'll be another 3D Vision product. But they seem like they're actually trying on this one, so we expect improvements. All right, we'll cover it later when it's patched up some more. Thanks for watching. Subscribe for more. As always, go to store.gamersnexus.net or patreon.com/gamersnexus to help us out directly. We'll see you all next time.